Hello everyone, welcome to India's largest e-learning platform, Gradeup. How are you all? Tell me who has joined the session. Mark your attendance guys, tell me who has joined the session, quickly. So I hope guys you are doing very well and just 4 days are left for your exam and I hope you are also doing your studies very well. Okay, so in the last class we have learned about the power system part 1. We have did some questions based on your generation, based on a transmission parameters. Today we are going to see the mix-up question. Okay, the question will be from the fault, the question will be from the stability, the question will be from the load flow analysis. So overall there will be a mixed question so that you will get idea about everything about the different topics from the power system. Okay. अविनाश बेटा यूपीपीएससी एई के लिए मैं पहले ही बहुत सारी क्लासेस ले चुका हूं. आप ऐप डाउनलोड कीजिए. ग्रेडअप ऐप है, आपको लिंक डिस्क्रिप्शन में मिल जाएगा. वहां पर मैंने पावर सिस्टम की और नेटवर्क की पूरी क्लास ले रखी है. काफी वीडियोस आपको फ्री में वहां मिल जाएगी. ओके, तो जस्ट डाउनलोड द ऐप, follow me on a Gradeup, okay, and after following me go to the section of a post and there you will see the UPPSC A section. Okay, and there you will see all the videos of power system as well as the network theory revision from my side. Okay, so let's start our today's session. Very quickly we will start our today's session. So as you all know, again the name is wrong, no problem. So first of all, about myself, my name is Ishaan Mudgal. I have a 3+ year of experience. I'm 5 times GATE qualified. I'm Tech gold medalist from NIT Allahabad, and these are my area of expertise. And guys, download the Gradeup app, follow me, and you can see a beautiful concept on network theory, power electronics, power system from my side. Okay, so we will start our class with this first question. So everyone try this question. Everyone try this question and give me the answer. Everyone try this question and give me the answer. A very good question. We'll start our class with this particular question. Okay, a very good question. Everyone try this thing. Yashwant, how can I install our application laptop, sir? Yashwant, go to our website and you have to make the account. Okay, you have to do the sign up. Just you have to do the sign up like any other website, and then you can watch the videos. Good evening Mikal. Okay, everyone इस session को फैला दो. Share this session with your friends so that they can also join the session and give the answers. Okay, power system पे last session है. From tomorrow I am going to take 2 classes on a power electronics, and the first class will be tomorrow for the power electronics. Okay, there will be a revision session only. There will be a 30 to 35 question tomorrow session also. So what is the question? In a short transmission line, the voltage regulation is 0 when the power factor angle of the load at receiving angle is given by. So let's see, a very easy question. Just for this question you need to understand one formula, the formula of voltage regulation. What is the formula of voltage regulation in per unit form? The formula is R per unit cos phi plus minus X per unit sin phi. Okay, multiply by 100. Okay, so now you should understand the plus comes because of the lagging load and minus comes because of the leading load. Now from this particular equation I can find out the maximum, minimum and zero voltage regulation conditions. In the question they are asking when the voltage regulation is 0. In the question they are asking a 0 voltage regulation. So beta, for a 0 voltage regulation there must be a subtraction. So 0 voltage regulation can come only in case of a leading. So I have to put voltage regulation 0 and I have to put the formula of minus X per unit sin phi equal to 0. Okay, from here you can find out the equation. Tan phi is equal to R per unit X per unit, right? And what is the phi? Phi is tan inverse of R by X. The option is option B, correct. So Savriti Priyam has given the right answer and all of you, good. Everyone has given the right answer, tan inverse R by X. And better remember one point, for zero voltage regulation, that can only happen in case of leading. If you want to find out the maximum voltage regulation, that can happen in case of a lagging, because in lagging you have a plus sign. And how to find out the maximum regulation? For maximum regulation, the differentiation of voltage regulation with respect to phi must be equal to 0. And just then you should find out the differentiation of this equation with respect to phi, put it equal to 0, you will find out that phi is equal to tan inverse x by r. So for the maximum voltage regulation, this type of condition will come. Correct. Next question. Next question, everyone read the question, and in this question I need to select which of these three statements are correct. Okay, so read the question carefully. Installation of capacitors at suitable locations. Installation of capacitor at suitable locations and of optimum size in a distribution system result in improved voltage regulation, reduction in distribution power loss, reduction of a kVA rating of a distribution transformer. So I have to select which of these three options are correct if I install a capacitor in a distribution system. Okay, think about each of these three statements very carefully and give me answer. So everyone try. Okay, I want answer from each one of you, and guys, don't forget to like the session. Okay, don't forget to like the session. Everyone like the session. Okay, that will be your attendance. And also don't forget to attend tomorrow's lecture. Also tomorrow will be of power electronics lecture, one of the important subject for your exam, for your Vizag exam, one of the important subject. Okay, so Ramadhisu has given the option B. Good. Vakas has given the option B, and Surya has given the option B. Okay, good. So all of you have leave the option C, right? Okay, so I have got 5 answers, and all the 5 students have leave the option C. It means you are leaving option 3. So let's see. First of all, I will discuss about the option 3 and then option 1, option 2. See, if you apply the capacitor, what is the first result you know in case of a capacitor? When you apply the capacitor, the power factor will increase. That everyone knows, right? For example, earlier the power factor is 0.8. If you apply the capacitor, it will increase from 0.8, reach to 0.85 or 0.9, any value. Now, what is the kVA rating? kVA rating क्या होती है? kVA rating is equal to kilowatt rating divided by the cos phi. Very important point. What is the kVA rating? kVA rating is kilowatt rating divided by cos phi. Okay, so if I apply the capacitor, cos phi increases. If cos phi increases, so beta kVA rating will decrease. So kVA rating will decrease. It means third statement is correct. About the first statement, obviously it will improve the voltage regulation because power factor will also improve. Reduction in distribution power loss, it is also correct. So all the statements are correct. Option 1, 2, 3. So option 1 and 2 were easy. Okay, you know the application of capacitor. Option 3rd was a tricky one. So you can see a kVA rating is equal to kilowatt rating divided by cos phi. So if cos phi increases, kVA rating will decrease. Correct. Next question. A very easy question, but one of the most important question that can come in your exam. And this question has been come in IES exam and in SSC JE exam and also in different exams. Okay. So in this question, the ABCD constants are given. We need to find out the sending end voltage is 400 kV. What will be the receiving end voltage under no load condition? And guys, if you have any doubt at any time, you can ask. Okay, koi bhi doubt ho, you just ask me. So the ABCD constant of a 3-phase transmission lines are given. Tell me the answer. A very easy answer. First of all, for ABCD, I know this is the equation. VSIS is equal to VR AVR plus BIR CVR plus DIR. Right? Fine. Now they are saying a no load condition. A very important statement. A no load condition is a condition where receiving end current is 0. So when receiving end current is 0, it becomes Vs equal to AVR plus 0. Now I need to find out the receiving end voltage, that become Vs divided by A. Now Vs sending end voltage is 400, A is 0.8, and absolutely correct, you are giving the right answer, 500 volt. Okay, Ramesh, hello Ramesh. Next one. Okay, this is again easy question. Right now we are doing the warm up. This is easy question. So Shanmukh is asking, is power system is useful for electronic and instrumentation post? Better for electronic and instrumentation, power system is not useful. They will not ask you the question. But if there is some exam for that particular post and they have given you the syllabus, and in syllabus if the power system they have asked, so yes, it will be useful. But according to me, for electronics and instrumentation, they will not mention power system in syllabus. Okay. Yes, beta. Yes, beta. Different. You can see different. A same question can come in different exam. Okay. Correct, Arjun Dev. Correct. Because you cannot create more and more question. Okay. Concept same ही है ना, concept same ही है. एक concept पे 100 question आ गए. They can just distribute those 100 question. Okay. Good. Now, okay, Kajal has given the option heavily loaded, but everyone has given the lightly loaded. Okay. Acha, tell me what do you mean by Ferranti effect? Tell me what do you mean by Ferranti effect? Anyone? Anyone can give me a 2 or 3 words about the Ferranti effect? A very important effect for your practical purpose also, for your exam purpose also. In a Ferranti effect, what happened? Receiving end voltage will be greater than the sending end voltage. Think about this phenomena. Think about this magic, that you are sending a voltage and at receiving end you are getting more voltage than the source. That is known as the Ferranti effect. And think about it, in this particular line, if this is sending voltage, this is receiving voltage, the current is flowing from lower potential to higher potential. But we always learn the current flows from higher to lower, but during the Ferranti effect, the current flows from lower to higher potential. And why this happen? All of this happen because one of the most important element of power system, which is capacitor. Because of the capacitive effect in medium and in long transmission line, you will face the Ferranti effect. Okay, in short transmission line, the capacitance is very low. That's why Ferranti effect is not that much appreciable. And second condition, the line must be a lightly loaded or no loaded. Okay, remember one point. First of all, Ferranti effect occur in medium and long transmission line. Next, it can occur when you have a no load condition or a lightly load condition. In case of a heavily load or fully load condition, the receiving end voltage will be less than the sending end voltage. Next question. So who has okay, yes, Anand has given the right answer. Arjun Dev, correct beta. Ramadev, so increasing of receive, correct. Vagas Mullah, the receiving end voltage greater than, yeah, correct beta, absolutely correct. Correct. Good. Do the comments like this. Okay, everyone. And if you have any doubt, beta, you can ask anytime. I'm again repeating myself. Now, this is the question based on the corona loss. So, as you can see, I have bring the mixed question. Because if you do only questions from one topic, then you will stuck to that topic. An exam is just 4 days ahead. So, in this way, you can do revision a very efficient way. So, see this question. The corona loss on a particular system at 50 Hz is 1 kilowatt per kilometer per phase. What is the corona loss at 60 Hz? Okay, everyone is giving the answer. CCC, good Ramesh, good Kajal, good Prabha. Acha, tell me about one thing. Tell me about one basic thing. Corona DC में होता है. Will there a corona effect in DC? Yes or no? Tell me. Corona DC में होगा? Yes or no? Yes or no? Will there be a corona effect in case of a DC supply, or it is just an AC concept? Tell me about this question. Yes or no? कोरोना डीसी में होता है या नहीं? Is corona is applicable in case of DC? Yes or no? Yes or no? Okay, Arjun Dev has given 17 by 15. Okay, fine. So let's see, solve this question very quickly. A corona loss, I hope you remember the formula, but more than the formula, there is a one part that you should remember, that corona loss is directly proportional to F plus 25. Okay, but better remember the formula also. Okay, the formula is little bit big, but you should remember it. Corona loss is equal to F plus 25. So in case of DC, first I will tell you about the DC. In case of DC, what happened? In case of DC, frequency becomes 0. So corona loss is proportional to 25. It means corona loss is not going to be 0. So remember this point. There will be a corona loss in case of DC, but the magnitude as compared to AC will be less. Because if you increase the frequency, the corona loss will increase. Got my point? Now come back to this question. So corona loss is directly proportional to F plus 25 for system frequency at 50 Hertz. For system frequency of 50 Hertz, corona loss is 1. I need to find out corona loss when frequency is 60 Hertz. 60 plus 25. Okay. So PC divided by 1. I can divide both of this. 85 divided by 75. So corona loss become what? Let me use the calculator. 85 by 75. कितना आंसर होगा? Option C. I guess option C, right? 1.13. Just use the calculator. Just use the calculator. It will be option C. Correct. Okay. Got my point? But remember, in case of DC, the corona will also present. But skin effect is not present in case of DC. Why? In last class, I told you the formula of skin depth. If you remember, in the last class, I told you the formula of skin depth. Okay, this is the formula of skin pi. This is the formula of skin depth. So you can see skin depth is directly proportional to 1 by root f. Skin depth is inversely proportional to 1 by root f. So if f is 0, what happen? Skin depth become infinite. Skin depth become infinite. It means you have a proper distribution of current in case of DC. So in DC there will be a corona but no skin effect. In AC both are present. Now next one, very important, and the topic is transient. And transient pe beta, I am telling you, they will ask you question, because I am observing the pattern from the last 2 years about this state exam, and I am observing that the transient question they are asking again and again. In one way or another, they are asking a transient question in case of power system. Okay, it's one of the important topic. Beta, Makela, if you're studying the mechanical engineering better, then why are you attending my lecture? It's for electrical engineering. Okay, so this one, everyone, if a line of surge impedance Z0 is terminated in an impedance Z, then the reflection of current and voltage surges at the termination are given by respectively. So guys, you should remember some formulas to know the concept of transient. Okay, see. This is the input voltage plus minus. This is the input voltage, or we can say incident voltage. In this, we can say this incident voltage. This is the transmitted voltage, and across this I have a reflected voltage. Okay. This is the surge impedance of a line. This is a load impedance, ZS and ZL. This is the surge impedance. This is load impedance. Now, few formulas you should remember for the transient. And almost every question will come from those formulas. And what are the formulas? First of all, transmission coefficient, transmission voltage coefficient. TV means transmission voltage coefficient. It is equal to 2 times of ZL divided by ZS plus ZL. Remember this formula? Transmission voltage coefficient. Which coefficient? Transmission voltage coefficient. Okay, fine. TV is this. Now next, you should remember RV, reflection voltage coefficient, is equal to 1 minus TV is equal to Z 1 minus, so ZL minus ZS. Sorry, ZS minus ZL. My fault. ZS minus ZL divided by ZL plus ZS. So ZS minus ZL divided by ZL plus ZS. Okay, next. Reflection current, reflected current coefficient. Reflected current coefficient is equal to minus of RV. So it will be equal to ZL minus ZS divided by ZL plus ZS. And current transmission coefficient is equal to, anyone know the formula? It will be ZS divided by ZL multiplied by TV. It means it will be 2 times of ZS divided by ZL plus ZS. Okay, so beta, you need to remember these formulas. And how can you remember this formula, you can ask. So beta, one way to remember the formula, you should remember this formula and this and this. Then every formula you can find out by yourself. So let's see what is given in a line of surge impedance Z0. Means now the surge impedance is what? Surge impedance is Z0 is terminated in an impedance Z. It means load impedance is Z. Then the reflection for current, means they are asking the Ri. So reflection of current Ri is equal to ZL minus ZS. It means Z minus Z0 divided by Z plus Z0. And voltage, reflection of voltage is equal to this formula. So you can see Z0 minus Z divided by Z plus Z0. Okay, is there any mistake I did? Is there some mistake that I did? Let me check it. Everyone check it, if I did any mistake or if the options are wrong. Everyone check it. Did I do some mistake? Let me check by myself. So no, they're asking the reflection for current and voltage surges. No, this is the correct answer. This is the correct answer. This is the correct answer, guys. This is the correct answer. So none of the options are correct. Okay, this is the correct answer. Maybe there will be some typing mistake. Okay, so this is the correct answer. Fine. Reflection. See very carefully. They are asking the reflection. If they are asking a transmission, then there will be a different formulas. Right? Good. Correct, Abhijit. None is correct. Now next question. Next one. And guys, don't delete the comments. Okay, don't worry. If you are giving the wrong answer, don't feel that you are giving a wrong answer. You are deleting a comments. Don't worry. Just give the comment. That is important. Okay. Okay. So everyone, for example, Kajal, Abhijit, and Priyam, you are deleting the answer. But better don't worry. If you are giving a wrong answer, that's a very good thing because you are learning a new concept then. So next question, if a traveling wave traveling along a lossless overhead line and does not result in any reflection after it has reached the far end, then the far end of the line, very important, very important. In this question they are saying, that reflection is zero. There is no reflection in terms of a voltage or in terms of a current. Means they are asking about a voltage current. There is not any reflection, and that can only happen if that terminated into a resistance equal to surge impedance of a line, and it can only happen if it will terminate into a resistance equal to surge impedance of a line. Why this happen? We just seen what is the formula of Ri. Ri का formula अभी हमने देखा, पीछे क्या था? Ri is ZL minus ZS divided by ZL plus ZS, right? Similarly, the formula of RV was ZS minus ZL divided by ZL plus ZS. Now reflection is zero. So if reflection is zero, put Ri equal to zero. When you put Ri equal to zero, it becomes ZL equal to ZS. If you put RV equal to 0, it is also become ZL equal to ZS. Okay. Now what is ZL? This is load impedance. This is load impedance. Okay. And this is surge impedance. So if that terminated into a resistance equal to the surge impedance of a line, then there will be no reflection. A reflection will only come. Listen this point very carefully. Listen this point very carefully. A reflection can only come if there will be a change in impedance. If there is no change in impedance, there will be no reflection. The whole wave will transmit it till infinite. Fine? Correct. Next one. Next question again. This is again the question of transient, and beta transient is going to be very important. So I want you to understand the concept of transients very well. सो इजी क्वेश्चन है, मुश्किल नहीं है. क्वेश्चन क्या है? द रिफ्लेक्शन कोफिशिएंट फॉर द ट्रांसमिशन लाइन शोन इन फिगर बिलो. Again, they are asking the reflection coefficient, but see one point, they didn't tell you which reflection coefficient they are asking. Okay, they didn't tell you which reflection coefficient they are asking, but no need to given that point. Why? Because see, the load is 400 watt, actually it is not ohm, not watt, because the load is 400 watt and surge impedance is 400 ohm. So if you are finding a voltage reflection or a current reflection, it comes out to be 0. Why? Because we have just seen this question, right? Otherwise, if there is some another value, then they should have given about the current reflection or the voltage reflection. Next point. Now this is the question from the load flow analysis. This is the question from a load flow analysis, and this is the question that has been asked many times in many exams. You will see this question in SSC JEE. You will see this question in GATE exam, and you will shocked to know that for the GATE exam, this question has been asked in the last 6 years. About 5 times this question has been asked in the last 6 years. Okay, and different AE exam and RRB JEE exam also this question has been asked. Not the same question, but this type of question in which you need to find out the size of a Jacobian matrix. So guys, if you don't know what is the meaning of Jacobian matrix, then you cannot attempt this question. Okay, and right now I can't explain you the Jacobian matrix because it will take much time to explain. Okay, so if you don't know about the load flow analysis, so don't worry, you can skip this particular chapter, because maybe one question will be asked, but for that you have to learn a many concepts for that. But students are giving the answer, and 4 students has given the answer, and all of them has given the right answer. Correct beta. Answer is 189 cross 189. So the people who know the meaning of Jacobian matrix, they know the order of Jacobian is given by which formula? It will be given by 2 times of n minus m minus 2 cross 2 times of n minus m minus 2. Now what is the n here? N is the total number of buses. N is total number of buses. What is m here? M is the PQ bus or PV bus? Can anyone tell me what is m? M is a PQ bus or PV bus? Think about it, guys. Tell me, M is a PQ bus or PV bus? M is a PQ bus or PV bus? Everyone, think about it. Give the answer in comment section. Give the answer in a comment section. PQ or PV? Correct. It is a PV bus. Now remember one point. Bacha. Remember one point, that if they have given 10 generator bus, if they are given a 10 generator bus and they are not mentioning anything about the slack bus, so always remember that slack bus is going to be equal 1 generator bus. Slack bus is going to be equal to 1 generator bus. So how many PV bus remain? Now PV bus remain is 10 minus 1 equal to 9. This is the number of PV bus. Remember, this point is very important. If they have mentioning anything about the slack bus, then all of the generator bus become the PV bus. Okay, but if if they haven't mentioned anything about slack bus, then one of the generator bus become the slack bus. Okay, now put all of this here. What is the total number of buses? 100. Minus, what is the PV? 9 minus 2, it comes out to be 189 cross 189. This is the order of a Jacobian matrix. Good. Next point. Next question. Everyone try this question. Everyone try this question. Everyone try this question. I need answer. Quickly, bachcho, quickly. The principal option obtained from a load flow studies in a power system are. Now, you should remember, you should understand one point, beta. Whenever you are going to create a power system, first of all, the first study that you should do is the load flow study. Why? Because load flow study will tell you what is the demand, and according to the demand, you will create the particular system. If you don't know the demand, how will you create the system, right? After the load flow study, you have to do the fault analysis. After a load flow study, we have to do the fault analysis, and after the fault analysis, we have to do the steady state analysis. We have to do the steady state analysis. Steady state analysis, or not, sorry, not steady state, my fault, stability analysis, not steady state, stability analysis. So this is the order of analysis that can be happen in case of a power system. First will be a load flow, next fault, next stability. Now they're asking the principal information obtained from a load flow study. So first of all, magnitude and phase angle of a voltage at each bus, obviously, because whenever you are going to create a power system, you should know about the voltages at each bus. Then you can generate that particular voltage. Reactive and real power flow in each bus, yes, because reactive and real power is actually the demand and the generation. For example, if you're connected some load, and if you don't know about the demand of that particular load, how will you fulfill that particular demand? So that will be done in the load flow study. Total power loss in a network, it is absolutely correct. Why? Because total power loss. Okay, why total power loss? Because total power loss will tell you about the losses that may come in your particular system. Transient stability, no. Load flow study doesn't deal with the transient stability. Load flow study doesn't deal with the transient stability. Answer is 1, 2, 3. So Abjidis sir, after load flow, I think we need to economic load dispatch. But economic load dispatch, the question from economic load dispatch has been asked in a very rare. That's why I haven't bring that particular concept. Okay, but for that particular concept, one thing you should remember: only one type of question will be asked. The question will be incremental cost will be equal in both the cases. So otherwise, apart from this, they will not ask you any question from the economic load dispatch. Okay, but the question are very rare that they have asked in different exam. Okay, that's why it's not very important topic. So next question. Now power is one of that topic you will absolutely going to face the question. You will face the question either in power system, in machines, in control, in network, but there will be at least one question that will come from the topic of power, and that too from the AC power, okay, because इसलिए कभी भी power के concept को मत छोड़ना. In this question, I need to find out the per unit value of a reactive power, and you have given a V sin omega t and I sin omega t minus 30. Okay. Ramesh has given the A answer. Good. Prabha A. Ramesh has given A answer 4 times. Good. Anyone else? So see, very easily. What is the formula of reactive power? Beta? The reactive power formula, remember the formula? Formula is V multiply by I multiply by sine phi. Okay, but there is a catch. Always remember, in case of a power, active or reactive, there will be a RMS voltage and RMS current. You should never multiply with the maximum voltage or maximum current. There will be a RMS voltage and RMS current. So you can see the V is given V sin omega t plus 30. So what will be the RMS voltage? RMS voltage is maximum voltage divided by root 2. Similarly, current is given like this. What will be the RMS current? That will be I divided by root 2 multiply of sine. The power, the phase angle difference between these two voltage and current. What is the phase angle difference? It is 60. What is the sine 60? What is sine 60? Anyone knows? Root 3 by 2. Sine 60 is root 3 by 2. So it comes out to be VI root 3 by 4. But they are asking the per unit value. Per unit value, it means what is the base? What is the base power will be V multiplied by I. When you divide these two things, then Q comes out to be root 3 by 4. Root 3 by 4. Okay, root 3 by 4. Remember this point. So answer is option C. Answer is option C, not A, D, A, D. So, okay, that's wrong. Remember, sine phi. In case of an active power, there will be a cos phi. Okay. So guys, next there will be information for you, a very important information. A Gradeup has given you now or never offer. Our price is going to be increased after 10 December. अगर आप इसको परचेज करना चाहते हो तो आप इसको परचेज कर सकते हो कम प्राइस में बिफोर 10 दिसंबर। और मेरी मानो तो एक बार अच्छे से मन लगाकर पढ़ाई करो, उसके बाद आराम से पैसे वैसे कमाओ, जॉब करो, बट एक बार एटलीस्ट आप मन लगा के अपनी पढ़ाई करो एक स्ट्रक्चर फॉर्मेट में, राइट। और स्ट्रक्चर फॉर्मेट के लिए अगर आप गेट के लिए पढ़ सकते हो, एई के लिए पढ़ सकते हो, जेई के लिए भी देख सकते हो। वी हैव सो मेनी कोर्सेज अकॉर्डिंग टू अ रिक्वायरमेंट ऑफ ईच एंड एवरी स्टूडेंट। For example, we have a gear up gate in which we will provide you more theory. In rank up gate, we provide you more numerical. And Vision 2022 is very important for the third year, also for the fourth year student who want to give gate in 2022. So they can prepare from this particular batch also. And in this, you will cover a numerical and theory in a very extensive way. Okay, and this is our star faculty from electrical department, and I know you have already seen many videos on this particular faculties, and you can see the year of experience they have. They can help you to score to get you a good job or some higher education that you want. Okay, and there is a Gradeup Super that is very important. A Gradeup Super will provide you two things. One is the structure life course, and one is the green card from where you can avail many mock tests, and also that mock tests are designed by toppers as well as the best faculties, and also you can compare your marks with other students. Okay, so let's continue our lecture again. So after giving you so much information, let's continue our lecture again. So in this question, you need to find out the per unit value of Y22 of the bus admittance matrix. So this is a question I bring from the bus admittance matrix. So think about this question. Give the answer. एंड बेटा ऑलवेज रिमेंबर, एक बार अगर आप पढ़ाई करोगे ना, उसको एकदम स्ट्रक्चर वे में पढ़ाई करो। एक बार अगर आप स्ट्रक्चर वे में पढ़ाई करोगे ना, आई एम गिविंग यू गारंटी दैट यू कैन स्कोर वेल इन एनी एग्जाम. इट मे बी जेई, इट मे बी एई, IES, GATE, whatever your dream, whatever you want, you can get it if you study in a structured way just once. Okay, so option B given by the Abjit. Good. Anyone else? What is the question? Acha, Y bus. You should understand some points about the Y bus matrix. Okay, what is the Y bus matrix? First of all, when you want to draw a Y bus matrix, all the particular elements must be in an admittance form. Okay, now they are written. The reactants marked are in per unit. They are given in impedance form. Why? Because impedance is nothing but resistance plus reactance, right? And I told you for the Y bus matrix, every element must be given in an admittance form. So first of all, convert every reactance into susceptance form. So when you convert this thing, you will get minus J10. When you convert this, you will get minus J10. When you convert this, you will get minus J5. Just check my calculation, okay? Minus J5 minus J5. Okay, fine. Now listen very carefully. When you want to find out Yii, when you want to find out Yij such that I is equal to J, it means I am talking about the diagonal element. I want to find out Y11, Y22, Y33, Y44. That is a diagonal element. So कभी भी अगर आपको diagonal element find करना है in case of a bus admittance matrix, then how can you find out? You just have to add all the admittance connected to that bus. All the admittance connected to that particular bus. For example, in this question, I need to find out Y22. So I will add all the admittance that are connected to a bus 2. So this is a bus 2. Now how this admittance, this one and this one are connected, so it become minus J5 minus J5 minus J10. It comes out to be minus J20. Option D. Minus J20. Option D. Correct. Option D. Right? But remember, you need to convert everything into admittance first. So this is about the principal diagonal. When you want to find out non-principal diagonal element, for example, Yij such that I is not equal to j, such that I is not equal to j. In that case, what is the formula? Formula is very simple. You need to write minus Yij. What is minus Yij? Admittance between two bus. Admittance between two bus. For example, I want to find out the element Y21. So Y21 will be negative of admittance between the bus 2 and bus 1. So what is the admittance between bus 2 and bus 1? It is minus J5, right? So minus of minus J5 equal to J5. Okay, and one more thing you should remember, that Yij is equal to Yji. It means Y bus matrix is a symmetrical matrix. It is a symmetrical matrix. So if I want to find out Y12, that will be equal to Y21. It is a symmetrical matrix. Okay, next point. Now this is an easy question. This one is very easy question. Okay, in this you have to identify what is the load bus, what is the PV bus, what is the slack bus, nothing else. Okay, so here I will tell you load bus is nothing but it is a PQ bus. Okay, PQ bus means the real power and the reactive power will be specified. What is the meaning of specified? Specified means given, or you can say fixed. So P and Q are fixed in a load bus. If you say about PV, then real power and magnitude of voltage is fixed. When you talk about the slack bus, in a slack bus voltage and a torque angle is fixed. Always remember, किसी भी power system में एक slack bus जरूर होगी. You will have slack bus in each and every power system. But it may happen in some particular power system there is no PQ bus, that can happen. There will be no PV bus, that can be happen. But slack bus is one of the most important and compulsory bus in every power system. Why? Because it is a reference bus. It is a reference bus. Whatever angle you are going to find out at any other bus or any other point, that angle will be referred from the slack bus. That's why. So option B, correct. Now this is the question about the fault current. Now this is the question of the fault current. A very easy question. If you know the concept, if you don't know the concept, then you have to leave this question in the exam. But here I will tell you the concept, because this type of question has been come many times in your different exams. Okay. So a relay is connected to this 400 by 5 ampere current transformer and set 150%. The primary fault current of 2400 ampere needs a plug setting multiplier of. Simple question hai, if you know the formula. A plug setting multiplier used where? It is used in a relay. Plug setting multiplier is equal to fault current in primary. Fault current in primary divided by secondary rated current. Secondary rated current multiply current transformer ratio multiply by current setting. This is the formula, and I am telling you this formula this particular question has been asked many times. Same question, the same language, just they have changed the values or magnitudes. So in this question, what is the fault current in primary? It is 2400. Fault current in primary is 2400 divided by secondary rated current. See, in this question, the secondary rated current is not given. If the secondary rated current is not given, then take secondary of the current transformer as a secondary rated current. Let me repeat myself again. If in the question secondary rated current is not given, then take the secondary of the current transformer ratio as a secondary rated current. Okay, multiply by CT ratio, which is 400 divided by 5, multiply by current setting, which is 150%, so multiply by 100. Okay, so 2400 multiply by 60, it comes out to be not 600, sorry, right? 600, yeah. So it comes out to be 4. Option B. Option B, yeah, option B. So everyone is given the option B. Yes, so you know the concept very well, bacha, because this question, इस question के आने के chances बहुत ज्यादा है. Okay, good. Next one, match the following. अब match the following question. This is the question linking the electrical quantities with their units. So you have to tell the answer. Okay, a unique question. Match the following. So you have a 4 electrical quantity given: magnetic flux density, shunt admittance, attenuation coefficient, phase change coefficient, and you need to tell me the units of each one of these quantities. Quickly. And again, I'm reminding you, tomorrow I will bring the question of power electronics. So be on time, correct, at 10 p.m. So Vivek Ajim has given okay, Vivek has given the option B, but Avjit has given the option D. Good. Everyone give the answer. Everyone give the answer. Kajal and Chamhari given sorry, D. Vivek has option the B. Okay. So B and D. B and D. सारे वोट B और D पर ही जा रहे हैं. तो let's see. Magnetic flux density. Everyone knows there's not any hard thing. The unit is Tesla. Okay, on the name of Nicholas Tesla. Shunt admittance. Shunt admittance. Think about it, beta. Shunt admittance. What is the unit of admittance? It is Siemens. What is the unit of admittance? Siemens, right? So the answer is short. It is option D. Why? A to B1, right? Why you are saying option 4? Why some people are saying option B? Option B is saying by some people. Okay, no beta. Think about the shunt admittance. The unit is Siemens. A very easy question. Now, what is the attenuation? What is the attenuation constant? The unit is Nepper, and phase change coefficient equal to radian. Do you know what is attenuation constant and phase change? It is represented by symbol alpha. It is represented by symbol beta. What happened? In case of a characteristic impedance, I told you the characteristic impedance is equal to what? It is equal to R. Sorry. Yeah. A characteristic impedance equal to what? Anyone knows? Right. So alpha and beta. Now beta, this is a part from the transient chapter in the long transmission line. Okay, you can do it by yourself. Fine, good. Next one, a very easy question. In this, you need to find out the ABCD parameter for the long lossless transmission line has a reactance of 0.3 ohm per kilometer. Okay, then neglect the shunt capacitance. So first of all, you need to identify that particular line. This line is the short transmission line. Now remember the ABCD formula in a short transmission line. Why the short transmission line? Because the short transmission line will be till 80 kilometers for the 50 Hertz frequency. Okay, so C option is given by some people. Let's see. See, in case of a short transmission line, what is the formula of ABCD parameter? The ABCD formula is very simple. A very simple formula. 101 Z, where Z is the total impedance. So it is given for the line you have impedance or the reactance of 0.3 ohm per kilometer. So what will be the total impedance? It will be 0.3 multiplied by 10. Why? It is given per kilometer. It comes out to be J3 because of reactance. Option C. Good. Next one. Now this is the question from the insulator. Everyone solve this question. I will give you some time. And right now everyone should solve this question. And guys, share this lecture with your friends so that they can also get benefited from this kind of lectures. So in a 3-unit insulation string, voltage across in a 3-unit insulator string efficiency is lowest. The statement is wrong. Statement is wrong. In a 3-unit insulator string, voltage across the lowest unit. Voltage across the lowest unit is 17.5 kV and string efficiency is this. String efficiency is this. The total voltage across the string will be. So as you know, what is the insulator? The insulators are present like this one. It is represented like a capacitor and each insulator has been represented by a disc. This is a ground capacitor like this and this is the power line. Okay, now what is the formula of string efficiency? What is the formula of string efficiency? The formula of string efficiency is total voltage divided by number of strings, number of discs multiply voltage across last disc, voltage across lowest disc, or you can say the last disc also, anything you can say. Okay, now what is the string efficiency? It is 0.8428, changing into a decimal. Total voltage I need to find out. Number of disc is 3. Voltage across the lowest is 17.5 kV. So let me use the calculator. 10.5 multiplied by 3 multiplied by 0.8428. So if I'm not wrong, it comes out to be 44.247 kV. It is the decimal. So it means option B. It means option B. Correct. 44.247 or you can say 25 kV. Correct. Next one. 3 generator rated this and this. The effective impedance of equivalent generator will be. A very simple question. And good bacha. Whenever there is simple question, everyone is given the right answer. Good. And better, these type of calculations will come in your exam. Because in a Vizag exam, there will be more questions, so they will not give you the lengthy calculation. They will give you the easy calculation in every subject. Or sometimes you will feel the calculation is lengthy, but there will be some trick for that particular question. For example, in control system. In power system, I am not telling you that there will be any trick in questions. But in a control system, in the network theory, if they are giving you some calculation which is very lengthy, it means that particular question will be solved by some trick and that they want to check. So very easy question, nothing worry about that. We have a 3 generator rated this thing and rated this much, having impedance of 0.15 per unit, and always remember a generator connected to a particular frequency in parallel mode. What will be the effective impedance of the equivalent generator? Simple. These three are connected in parallel. So 0.15 divided by 3 gives you 0.05 per unit. No worries. No worries. Option A. Correct. Next one. Now, one of the important question, and these type of question will come from the topic of fault analysis. One of the question will definitely come from the topic of fault analysis. What is the question? Read the question very, very carefully. If all the sequence voltage at the fault point in a power system are equal, then the fault is which type of fault you have. So I will give you some basic information. If you know about it, then it's very good. Otherwise, understand this basic thing. Three-phase fault. In a three-phase fault, positive sequence current is not equal to 0. But a negative sequence and a zero sequence current will be equal to 0. Okay? In case of a line to ground fault, positive current, positive sequence, negative sequence and zero sequence current are equal. Okay? And in case of double line fault, we talk about in case of double line fault, IA naught is equal to 0. But positive current is equal to negative sequence current. In case of double line to ground fault, what happens? The summation of every fault is equal, every sequence current is equal to 0. And one of the most important point, the voltage here will be same. the voltage here will be same. So answer is option D. In case of double line fault, what will happen? In case of a double line fault, voltage of A1 is equal to negative of voltage of A2 and voltage of A0 is equal to 0. In case of LG fault, what will happen? VA1, VA2 plus VA0 is equal to 0, and here VA0 equal to VA2 equal to 0 and VA1 is not equal to 0. So this particular relation you should understand. Okay, and this you can only understand if you have learned the fault very carefully. If you haven't learned the fault very carefully, then you cannot give answer for this type of questions. So next question now. A few questions are left. The time is already up, guys. Time is already up. So I will just take one or two questions more. So what is given? In a 220 kV system, the inductance and capacitance of the circuit breaker are given. We have given L is equal to 25 millihenry and capacitance is given 0.025 microfarad respectively. The value of resistor required for this. A very simple question. Whenever you don't require a transient oscillation, the resistance must be equal to 1 by 2 under root of L by C. So when you put the value of L, C in this particular question, you will get the answer 1000, which is option D. Which is option D. Okay. Okay. So this is your homework question. Take this question homework, and guys, you haven't solved the previous day homework question. Yesterday homework question you didn't solve. I told you you have to give the answer in a comment section, and you haven't given the answer. Only one student has given the answer. Okay, so this is the homework question. This is your first homework question. This is your second homework question. Take the screenshot. Take the screenshot. Okay, quickly take the screenshot. This is your third homework question. Question number 3. This is the third homework question. Quickly take the screenshot, everyone. For this question, you can give the answer directly now. For this question, you can give the answer directly. Mode relay is usually employed for the protection of which type of line? Mode relay is usually employed for the protection of long lines only. Okay. For protection of short line, you have to use the reactance relay. For protection of medium lines, you have to use the impedance relay. Okay, guys. So I hope you enjoyed the lecture. You have learned something which is for your exam. Okay, and we have solved approximately 30 plus questions in today's class. Okay, so do the homework, give the answer in a comment section. Okay, and अच्छे से power system prepare करो बेटा. One of the most important subject for an electrical engineer. Okay, and all the best for your Vizag exam. And tomorrow I will come live on the same time 10 PM for the power electronics. So we will see some good questions on the power electronics, right? And थोड़ा सा revise करके आ जाना. And just revise the power electronics so that you can able to give answer in tomorrow's class. Till then, bye bye, take care, enjoy करो, पढ़ाई करो and मजे करो.